Alright guys, we're back. I'm kind of mad because I made 95% of this video on my phone, and then my phone said it's out of space and just stopped recording. I was in this room talking to myself. So we'll restart. So today is second day of graphing, because graphing is a big task, and I want you guys to get more practice with it. So we're still on topic 2.2, and we're going to talk about what these things mean, filling out this table. So what this means is if f prime of x, so the derivative, if the derivative of f of x is 0, what does that mean about the function? Well, let's remember that the derivative is the slope at a point. So if the slope at a point is 0, so if the slope at a point is 0, what does that mean about the function? Well, if the slope is 0, let me just get my pencil. That means that the slope is a horizontal line. How could you have a slope that's a horizontal line? Because the point is touching something like that, right? There's a tangent line at that point. So the slope at a point, the slope at a tangent line to that point, right? So that means that the only way you can have a slope of 0 is if there's a relative min or a relative max in the function, right? And I'll write that out. Right? So you have some sort of peak or some sort of bottom out, right? Because it results in a horizontal tangent line. Okay. Well, what about when the slope is greater than 0? The slope is greater than 0. The derivative is greater than 0. Well, if the slope is greater than 0, the function has to be increasing. And going the other way, if the slope is less than 0, the function has to be decreasing. Okay, if the derivative or the slope is changing from positive, so the slope's going up and then it goes down to negative, so it's changing from positive to negative. What does that mean about the function? Well, that means there's a relative max at that point. And if it's changing from negative, so the slope's decreasing, then it's going up to positive. In that case, you have a relative min. Okay? So those things are just to help you think about the graph, because there will be times where you'll be given a derivative and that you have to think, well, what does that mean about the graph of the original function? So let's do that. Here's f of x. We need to graph a possible graph for f prime of x. So this is a graph of the derivatives of the function. Or the other thing you could think about it is it's the graph of the slopes of that function. The slopes at each point. Slope with a tangent line, right? So let's do this. I always like to start with the zeros. Those are called our critical points. So where does the derivative equal 0? Well, there's 3 points on this graph where there's a relative min or a relative max. Here, here, and here. So the slope is 0 at negative 1, 2, 3, 4. Slope is 0 at negative 4. Slope is 0 at, let me use a bigger pen. Slope is 0 at 1. And the slope is 0 again at 5. So those are 0 on this graph because the slope is 0. Now what happens between them? So let's look left of negative 4. So if I look left at negative 4, the slope is increasing. The slope is increasing. We know that the derivative is greater than 0, right? The slopes are positive, so we have to be in the positive part of this graph. So we're up here somewhere. Now let's figure out where we should be. Now the slope starts off pretty steep, very positive, and as you go along this interval, you see it gets less steep or less positive. So it starts off very steep and gets less positive. So less steep. So that means that we're starting up here very positive and then we're going down to be less positive. So this is just a sketch. So I'm just going to draw something like this. Right? Starting off very positive and going less positive. Okay, what happens between -4 and 1? Well, I know I have to dip down and come back up, or I'm going to be going up and coming back down, because I need to connect these two, right? I doubt it's going to do anything crazy like that, but let's see. So I'm looking at this. In this section, the slope is decreasing. It's going down, right? Okay, so that means the whole derivative in this interval is negative because it's decreasing. So we're down here below the x-axis. So I know I need to come down and turn around at one point to hit this. So where do I turn around? So if I look at this, my slope starts off slightly negative and gets more and more negative. It gets the most negative here, and then it turns around again and gets more and less negative, right? So you can see that turnaround point is somewhere right here, right around x equals 1, -1. So I know I'm turning around x equals -1. So I'm just going to sketch something like that, right? Now let's do this part. Looks similar between 1 and 5. Between 1 and 5, my slope is increasing, and it's almost the same as the last one, except it starts off less positive, gets more and more positive, and then becomes less steep or less positive. So it's like the opposite of that one, right? And then what happens when we go past 5? Past 5, the slope is decreasing. It starts off less negative and gets more and more negative as we go. So this is just my sketch. This is what it could look like, the graph of the derivative, okay? So the reason we're doing this is sometimes you see some multiple choice questions where you'll be given the graph of f, or you'll be given the graph of f prime of x, and you have to look through some possibilities and find the one that matches. Okay, we're going to do a little bit more of this in a different way. So here's our second example. Approximate the value of f prime of 4. So we need to find the slope at x equals 4. So to find the slope at x equals 4, let's go to 4. 1, 2, 3, 4 here. Okay, we need to make a tangent line there. But it's asking us to approximate. So if we're approximating, we're just going to use the slope formula. So let's pick 2 points we know, right? 1, 2, 3. I realized I didn't put an x. 4 is actually up here. Let me write that. This is x equals 4. Okay, so let's pick 2 points we do know. We know where x equals 3, and we know the value at x equals 5. So let's use those 2 points by making a secant line and finding the average rate of change, because 4 is between 3 and 5. So, what's this pen? So we have the first point is 3 minus 1, and the second point is 5, 4, right, from the graph. So let's find the slope. y2 minus y1 over x2 minus x1 is equal to 5 over 2. So f prime of 4 is about 5/2. That's our approximation. Here we just use the slope formula. 4 is between 3 and 5. So it's about a positive 5/2. Okay, next one. At what values of x is f prime of x equal to 0? So when is the slope of the tangent line going to be 0? Well, if we look back at our first page, the slope is 0 when we have a relative min or a relative max. So where do we have those? We have one here, and we have one here, and we have one here. So slope is 0 when f of x has a relative min or max. So for this case, that's when x equals -4, 1, or 5. Pulled those right from the graph. On what open intervals is f prime of x less than 0? So f prime of x is less than 0 when the function is decreasing. So f prime of x is less than 0 when f of x is decreasing. This is my justification. So for this graph, that is when's the slope negative? It's negative between here, -4, and here, which is 1. And also after this point of x equals 5. So this is just saying union or and to infinity. So the opposite of that, what is it? Positive. What is f prime of x positive? F prime of x is greater than 0 when f of x is increasing, straight from the table. So where is this thing increasing? A positive slope is from negative infinity to 4 and from 1 to 5. At what values of x does the graph of f prime of x go from being below the x-axis to above the x-axis? So if f prime of x is changing, it's changing from below the x-axis, so negative, to above the x-axis is positive. If f prime of x is changing from negative to positive, we are talking about a relative minimum. F of x has a relative min. So where's the relative minimum? Here, at x equals 1. It's the only place the slope is 0 and it's turning around, relative min. So then this is the same answer, or same question, but the other way around. So when is f prime of x changing from being below the x-axis or negative to above the x-axis to positive? So it's changing, this needed a when in there, when f of x has a relative max, right? So where is the slope changing from negative to positive? I just wrote this the wrong way. I'm tired. When does the f prime of x go from being above the x-axis, so positive, to below the x-axis to negative, right? It's the opposite of this one. So the relative max is when we're going up, boop, 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 and then switching and coming down. So that would be at x equals -4. And also, again, increasing to decreasing at x equals 5. Okay, next one. I think you should pause it and try it, and then turn it back on and see if your answers match. So that's my suggestion. So do that if that makes sense to you. Well, this time we have a graph here. This time it's the derivative of x. And it's saying it's on the interval -3 to 4. Okay. And it's going to ask us some questions about the original function f of x. So on what open interval is the graph of f of x increasing? So f of x is increasing when what? Go back to our table. F of x is increasing is when the derivative is greater than 0. You can use your table now, but this stuff will become ingrained in your head like your times tables. So f of x is increasing when f prime of x is greater than 0. When is this thing greater than 0? Only right here, only this section. This is the only part of the line that's above 0. So it would be from -3, from -3 to -2. Okay? On what open intervals is the graph of f of x decreasing? So this is the opposite of this, right? F of x is decreasing when f prime of x is less than 0. So when is this function less than 0? Well, it's less than 0 from -2 to 2. It's not it because right here x or y equals 0. So we're going to say it's from, -3. No, I'm right. From -2. We're looking for when it's below, so this part. When is it less than 0? When it's decreasing. So when is it less than 0? It's less than 0 here, here, and then again here, but not at 2. At 2 it is 0. So it's less than 0 from -2 to 2, and again from 2 to 4. So this section and then that section. The derivative is below 0. At what value of x does the graph of f of x have a horizontal tangent line? So f of x has a horizontal tangent line when what? When the derivative is equal to 0. So where is this derivative equal to 0? At 2 points. I see it's equal to 0 when x is -2, And I see it's equal to 0 when x is 2. At what values of x does the graph have a relative max? Coming back here, when do we have a relative max? When the function is changing from positive to negative. So when the f prime of x is changing from positive to negative, that's when you have a relative max, right? So f of x has a relative max when f prime of x changes from positive to negative. So where does this thing change from positive to negative? There's only one spot. It goes from positive here to negative below the x-axis there. So for our answer, it's x equals -2. What about the opposite way? When is there a relative minimum? Well, to have a relative minimum, let's write that as a relative min when the derivative, f prime of x, changes the other way around from negative to positive. So here the slope is negative, the derivative is negative, and it never changes to positive. Once it goes down here at x equals -2, it stays negative the whole time. So this does not exist. No relative mins. Okay, one more example. I know the video is long. It's a bit of a kind of a word problem here. It's not a word problem, but you're going to have to use what we learned in 2.1 and combine it with 2.2. So you have this function, and the directions say to determine the intervals for when it's increasing or decreasing, okay? And also to find the coordinates of the relative extrema. That just means the min or the max. So we're doing two things, finding where it's increasing, decreasing, or the min or the max. So the first thing we need is we are going to use the derivative here. You could graph this and figure it out on your own, but let's use the derivative. So if we need to find the derivative, remember we have to use our definition of a derivative, and I'm going to use the one with an h in it. If you don't like the one with an h in it, you can use the other variables, but I'm going to do that, okay? So if I'm taking the limit as h goes to 0 of f of x plus h, it's going to be x plus h cubed minus 6x plus h plus 1, then take away the original function. So take away x cubed. I'm going to distribute this minus here. Plus 6x minus 1 all over h. Now I just need to simplify, okay? So I worked out how to cube this. If you want to pause and read through that, I'll tell you to cube it. You can also look up the rule if you don't want to do all that. But I'm just going to go ahead and write what you get. So when you cube that thing, you get x cubed plus 3x squared h plus 3x h squared plus h cubed. So that's what that thing is. When you expand it, then you have minus 6x minus 6h plus 1 minus x cubed plus 6x minus 1. Whoop, all over h. Exhausting. Now let's see. Hopefully some of this cancels out. Yes, x cubed minus x cubed. Minus 6x plus 6x plus 1 minus 1. That's it. Okay. Now let's rewrite what we have. Now we can take out some of these h's. H, this becomes h squared. This becomes h goes away. So the limit is h goes to 0 of 3x squared plus 3xh plus h squared minus 6. Okay, now we can plug in 0. I'm not having the 0 in the denominator. I got rid of it. So now let's plug in 0. So this equals 3x squared plus 3x times 0 plus 0 squared minus 6. These go away. The derivative, f prime of x, equals 3x squared minus 6. That's a derivative of that function. This derivative is going to give you the slope at any point. Okay? But remember, the whole point was to find the min or the max in the increasing or decreasing. So if we need to find the min or the max, going back to that table, the min or the max means when the slope is 0. So when is the slope 0? When is the derivative 0? So we need to find those critical numbers. Critical numbers is when f prime of x, or the slope, is 0. So let's figure out when is the slope 0. Let's substitute in. 0 equals 3x squared minus 6. Where is that true? 6 equals 3x squared, 2 equals x squared, positive or negative root 2 equals x. So the critical numbers are at negative root 2 and positive root 2. Those are where the slope are 0, and I'm putting them here. So this is, I'm just going to write it here. Slope equals 0. Actually, I'm not going to write that. I'm going to write f prime of x equals 0. And this is just what we call a sign chart because it helps us keep track of everything. So I put the dots or these points as critical numbers because that's where the slope is 0. So I know there's a relative min or max there, okay? So now if we know where it's increasing and decreasing, that'll help us figure out where the relative min or max is. So to test that, where it's increasing or decreasing, you can just pick some test points. So let's pick a number that's less than negative 2. So my test point here is going to be negative 2. What's a test point between negative root 2 and positive root 2? Okay, that test point is easy. I'm going to choose 0. You can pick any number that's easy to work with. And then a test point that's greater than root 2, I'm just going to stick with 2 again. So I have positive and negative 2. And then we just plug those in to the derivative and see what we get. So when I plug in negative 2, f prime of x equals 3 times negative 2 squared minus 6. So f prime of x equals 3 times 4 is 12 minus 6. So this whole thing is positive. All I really care about is the sign. Because they didn't ask us for values, they just asked us where it's increasing or decreasing. If f prime of x is positive, I know this thing is increasing here. And then let's plug in 0. F prime of x equals 3 times 0 squared minus 6. F prime of x equals negative 6. So this thing is negative. On this interval, we are decreasing. Let's plug in 2. Okay, I can already see I'm going to get the same value here because the square means the negative doesn't matter. So here my f prime of x is positive. That's all I care about, increasing. Okay, so what does this mean? How do we answer this question? For each, so we need to first find relative extrema. So we know that these critical numbers are possible candidates for relative extrema. They might be mins or maxes. How do we know if they're mins or maxes? Well, it has to have the slope equal to 0, the derivative equal to 0. Check, that's true, we check that. Is there one of them where the slope changes from positive to negative? Yeah, the slope changes from positive to negative at negative root 2. So this right here is a relative max, okay? Are there any relative mins where the slope changes from negative to positive or the derivative changes from negative to positive? Yeah, right here. Here's a relative min. So we just did all of this work to figure out these things. So how would we write our answer? I'm going to write it on a new sheet of paper so I don't squeeze this all in. Let's see. I'll write it here. Okay. Now let's write f of x has a relative, we say, max at x equals negative root 2 because f prime of negative root 2 equals 0 and the function is changing from increasing to decreasing. Here's part 1. Part 2, f of x has a relative min at x equals positive root 2 because, why? f prime of root 2 equals 0, and f of x is changing opposite this time from decreasing to increasing. The last statement is to give all the intervals for where it's or where it's increasing or decreasing. So we would say f of x is, let's check, it's increasing on these two intervals, right? So it is increasing from negative infinity to negative root 2 and root 2 to infinity because, why? F prime of x is greater than 0 on these intervals. Last, f of x is decreasing from negative root 2 to root 2, right? This middle part. Because f prime of x is less than 0 on this interval. So what happens a lot of times is on FRQs, students do this, all this work, you have it here, great, but that's not a statement. This is not, you need to write it out in sentences to explain what's happening. You cannot expect the AP reader to decode all this. You need to say these things. So these are the statements, although they seem repetitive and like, oh, you could read that from the graph. If you want to get points on FRQs, you need to write them all out. So I know that was a lot of problems. But like I said, it will get more familiar the more we work with them. Okay? Signing off.